This is the 8.3 homework video answer key. This is only an 8 problem homework. The first 4 are all the exact same in the sense where you have 2 sides and an angle. The last 4 are all the exact same in which you have 3 sides and you're missing all 3 angles. I'm just going to go ahead. I'm going to do number 9, which is the first of the 2 sides and an angle, and number 13, which is the 3 sides. These are the exact same 2 examples you have in your notes. I want to make sure that you have a couple more examples on doing this. This should be pretty straightforward. It's a lot of plug and chug. It might be a little bit of tedious math that you have to do over and over, but I want to make sure you have those examples there. So looking at number 9, I'm given, I know that my side length C is 4. I know my side length A is 2. And I know my angle B is 45 degrees. I'm kind of forced to figure out which thing that I have to solve for first. In this case, I have to solve for my side C first because of the other 2 sides and the angle I'm given. If you're given 2 sides and an angle, the side that you have to solve for the law of cosines, is the one opposite the angle that you have. So since I have my angle B, I have to solve for my side length B. B squared will be equal to 2 squared plus 4 squared minus 2 times 4 times 2 times the cosine of 45. So B squared will be equal to 4 plus 16 minus 16 times the cosine of 45. B squared will be equal to 20 minus 16 times the cosine of 45. And then B will be equal to the square root of 20 minus 16 times the cosine of 45. I'm just going to go ahead and plug that into my calculator. I know that I didn't do that in the notes. I did a lot more work in the notes, but that's not my goal there. I'm just looking for... I could have done all that. I could have gotten a lot more specific here, but knowing that the cosine of 45 is not a fraction like it was easily, I know that I'm going to have to plug this into my calculator anyway, so I might as well just go straight to it. So I'll say 20 minus 16 times the cosine of 45 degrees, and I'll plug that into a square root, and I'll find that I'm looking at a side length of 2.95. Ugly side length that's going to make the rest of the math not the prettiest, but again, I'm just going to go ahead now and work with my law of cosines to go forward. Now I know all 3 side lengths, and I can use all 3 side lengths to solve for any other angle. The angle B really doesn't do me any good anymore until the very end. I'm just going to work in alphabetical order and find my angle A. So now I'll say 2 squared is equal to 4 squared plus 2.95 squared minus 2 times 2.95 times 4 times the cosine of A. This will be 4 is equal to 16 plus 2.95 squared is 8.7025 minus 2 times 2.95 times 4. Sorry, my calculator is working extremely slow today. So that gives me a value of 23.6 times the cosine of A. So this is 4 minus 16 minus 8.7025. So that's negative 20. Sorry, my calculator is apparently working extremely slow. Negative 20.7025 is equal to negative 23.6 times the cosine of A. So divide by negative 23.6 divided by negative 23.6. So now the cosine inverse of positive 20.7025 over 23.6 will be equal to A. And so I'm just going to plug that in on my calculator. The inverse cosine of 20.7025 divided by 23.6. And I will find that this means my angle A is equal to 28.7 degrees. Now, this does hold up. This makes sense. My angle B was 45 degrees and gives me a side length of 2.95. My side length A is smaller than that side length B, and it gives me a smaller angle, so that's good. That makes sense. Now I'm going to go through to solve for C. I'm going to do 180 minus 28.7 minus 45. I could go ahead and plug all of this back in, but doing the formula and doing all the work associated with the formula is tedious. I will find that my angle C is equal to 106.3 degrees just by doing the subtraction, which makes sense given the fact that C is my largest side length. Now you can plug this in. If you want to do a check for your work, you can go through and say 4 squared is equal to 2 squared plus 2.95 squared minus 2 times 2.95 times the cosine of C. You can plug all that in. You can solve for your inverse cosine, and you can find that C is 106.3. That is just a way to check your work here. The book would have you do this anyway. I don't think it's necessary. Just go through and do the subtraction. Save yourself a little bit of time. If you're concerned about your answer, you can always do that check. All right, the other question I'm going to do here is number 13, because that's the first one you have, where you just have all three sides. So when you're given A is equal to 6, B is equal, these are all the lowercase letters, sorry. When you're given A is equal to 6, B is equal to 5, and C is equal to 8, all you can do here is solve for angles. You get a choice of which one you solve for. It does not matter which side you solve for. I'm just going to work in alphabetical order because, again, why not? So I get 6 squared is equal to 5 squared plus 8 squared minus 2 times 5 times 8 times the cosine of A. 36 is equal to 25 plus 64 minus 80 times the cosine of A. Do your subtraction here. So that's, let's see, that's positive 11. So then that's negative 53 is equal to negative 80 times the cosine of A. We'll divide out negative 80. And we'll end up with the cosine of A is equal to 53/80. And then A is equal to the inverse cosine of 53 over 80. So I plug that in. And you end up with your angle A is going to be equal to 48.5 degrees. This holds up. It shouldn't be bigger than C. It's going to end up being bigger than B, so we'll see what angle. Let's go ahead, stick with alphabetical order, see what your angle B is. So now we're going to say 5 squared is equal to 6 squared plus 8 squared minus 2 times 6 times 8 times the cosine of B. 25 is equal to 36 plus 64 minus, that's going to be 12 times 8, 80, 96 times the cosine of B. We'll subtract everything out. So that ends up, now that's negative 11. So this is negative 75 is equal to negative 96 times the cosine of B. The cosine inverse of 75 divided by 96 will be equal to B. So we'll set that up and figure out what that is. and we find that B is equal to 38.6 degrees. That makes sense because B should be smaller than A, given the side length of A being the middle, B being the smallest. And then we're just going to go ahead and solve for angle C by doing your subtraction. So that's 180 minus 38.6 minus 48.5. Plugging that in on my calculator, and when you plug that in, I could do this in my head, but that just seems a little bit extra right now. I find that my angle is my calculator is never moved this slow. Angle C is 92.9 degrees. That makes sense given how much larger it is than the other two sides and proportionally how much larger this angle should be. I'm fine with that answer, but again, if I really wanted to, I could go through and I could plug this in to 8. 8 squared is equal to 5 squared plus 6 squared minus 2 times 5 times 6 times the cosine of C. I could plug all of that in and I could find my answer. Interestingly enough, here, this actually kind of displays something. 64 is equal to 25 plus 36 minus, let's see, that's 60 times the cosine of C. You'll see here when you do this, minus 25 minus 36 minus 25 minus 36. This is actually the first case where you would end up with a negative angle. So when you do that, and I don't even have to jump too much farther than right here, you would see that in this case, you would end up solving here once my calculator decides to operate at a semi-normal speed. Or I could just go ahead. So this gives you positive 3. And that's negative 60 times the cosine of C. So then, when you do this, you actually end up with a negative number for the first time. And this is what I was talking about in the notes, in the case that I don't have to solve for anything. So now I've got negative 1/20th is equal to the cosine of C. Or that the cosine inverse of negative 0.05 would be equal to my angle C. When I have that negative, it's going to just give me the angle that I've always wanted. It's going to give me the angle in quadrant 2. So this is why I don't have to solve and see which angle that I'm actually looking at. I always knew that this was going to be an angle in quadrant 2 because of that. So I just wanted to do that as a quick aside because it actually worked out. And it shows you, unlike the law of sines where you have to solve and see if you have two triangles, if you could potentially have that quadrant 2 angle, it's not going to happen in cosine because it's just going to tell you if it's a quadrant 1 or 2 angle. So that's all I've got for the video answer key. If you guys have any questions or concerns, please reach out sooner rather than later, and have a great night.